Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. Okay, we will continue our lecture into second types of sensor in position, displacement and level sensor, which is capacitive sensor. Okay, so the capacitive displacement sensor, it has a very broad application, which is usually they employ directly to gauge displacement and position, and also as building block in other sensor where displacement are produced by force, pressure, temperature and others. So the ability of capacitive detector to sense virtually all materials makes the capacitive sensor is very attractive choice for many applications. Okay, so how is it the capacitive sensor working? Okay, we know that previously we already discussed about the capacitance, right? We know that the capacitance, the equation for capacitance is C is equal to E naught C is equal to E naught A over D. Alright, see, which is the value of capacitance will depends on the depends on the dielectric material, and then the area and also the distance between plate. D is the distance between plate. A is the area. This one is the value of the electric material, right? Okay, so from the equation we know that the capacitance is the inversely proportional to the distance between plates and directly proportional to the area. Okay, so the operating principle of a capacitive gauge proximity and position sensor is based on either we change the distance between the capacitor plates, or we vary the capacitance in the presence of conductive or dielectric materials or the area. Okay, so when the capacitance change, the value of capacitance can be converted into variable electrical signal. Okay, another one is capacitive sensor. It can be either we use is a monopolar, which is we use just only one capacitor, or differential by using two capacitor, or a capacitive bridge that can be employed by using four capacitor. When we use two or four capacitors, one or two capacitor maybe we need to fix it, or variable with opposite phase. Okay, how does the capacitive sensor working? Okay, so if we look at this figure, okay, there are three plates, which is C1, 1, 2 and 3. Okay, so from 3 plates it can make it into 2 capacitor, okay, which is C1 and C2. Alright, okay, C1 and C2, which is the distance between two plates is nearly equal. It notes like as x naught, x naught. So the distance between these two plates is equal. Okay, so this one is the distance between two plates, x naught. Okay, so the upper, if we know, if we look at here, V naught and negative V naught. Okay, so the upper and lower plates are fed with the out of phase sine wave signal, which is the signal are phase shifted by 180 degree, which is one is positive V naught sin omega t and another one is negative V naught sin omega t. So the both capacitor, the value are nearly equal, and make it the center plate that there is no voltage because the current through C1 and C2 are cancel each other. So The central plate will indicate the voltage across it is V naught V is equal to 0 volt. Alright. Okay. So how does it change? How does we make we change the position of the central plate? Okay, so now we move downward the plate. Okay, so if we can, you can see here, right, this one. Okay, so now the plate is moved downward, which is makes the upper level the distance becomes x0 plus okay, so the upper level makes the distance between plate becomes x0 plus x, and the lower level x0 minus x, because the distance in C2 is decreased and the distance between plate on C1 is increased. Okay. Alright, so what happened when we change the distance between plate? Of course, our value of capacitance will be changes. Alright, so how we want to calculate the value of capacitance in C1 and C2? Previously, we already mentioned that capacitance can be calculated by using this equation, right? C is equal to E naught A over D. Alright, so the original value for C1 and C2, it's become C is equal to E. Okay, so C is equal to E naught A over X naught. Alright, now the value of C1 will become C1 is equal to E naught A over X naught plus X. Alright, and the C2 it will become E naught A over x naught minus x. Alright, so the value of capacitance for C1 and C2, it will not the same as previously. It will become different. Alright, okay, so okay, so when the value of C1 and C2 is different, the output voltage that will become out, it will be also is not is equal to 0. They will give some indication of the value on the output voltage. Okay, so how we want to calculate the value of output voltage? We can use this equation, which is V R is equal to V naught X over X naught plus X plus delta C over C, which is delta C is the change of capacitance, the changes of capacitance. Alright, so that's how the working how the capacitive sensor working principle, how it make how displacement make change and detects by using capacitive sensor. I hope all of you will understand this lecture. We will continue into inductive sensor in the next video. Thank you.